Alright, ladies and gentlemen, in this video we are going to focus on a goal of identifying some key characteristics of inscribed polygons within a circle. Now specifically, we're going to be focusing today on right triangles and quadrilaterals that are inscribed in a circle. Okay, so let's just keep in mind that a polygon is inscribed. Technically, it's considered inscribed when all of the vertices lie on a circle. So this pentagon right here is an example of an inscribed polygon. All of the vertices are on the circle. We would consider the circle to be a circumscribed circle because we circumscribed it about the pentagon. So for our right triangles and our quadrilaterals, let's talk here for a sec. If specifically a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle, and it works both ways. If one side of an inscribed triangle is the diameter, then the triangle is right. Super important, okay? The only way that basically we're saying is a right triangle fits inside or inscribed in a circle is if the hypotenuse is the diameter of the circle. Okay, and remember, to be inscribed, it has to be on all vertices have to be on the circle. So I'm not just saying the only way I can put a right triangle in the circle is to have the diameter or hypotenuse. I'm saying the only way that I can inscribe it by specifically having the vertex on the circle. Okay, so let's take a look here at an example where we focus that specifically. So in this example here, we see that AB is the diameter, and it wants to know the value of x. Well, if AB is going to be the diameter, that means this angle C had to have been a 90-degree angle. And so if it's a 90-degree angle, well, then we set the value equal to 90 degrees. And of course, x is going to be 45 in this example. So what I did was we realized it's one, inscribed by having all vertices on there, and two, it is the diameter, so that means that this was a right triangle. Let's go back to our quadrilaterals. A quadrilateral can be inscribed if and only if its opposite angles are supplementary. Again, inscribe all vertices on the circle. The only way that this works is if D and F add up to 180 and E and G add up to 180. The opposite angles have to be supplementary to one another. Okay, I do want to challenge you, if you want to take a look at your textbook, there is a great proof that is on page 560 of how this actually works. So I kind of challenge you to kind of look outside the box there at that proof as well. So let's take a look at an example. Here's our inscribed quadrilateral, D, G, F, E. D and F have to be supplementary. That means that the measure of angle D plus the measure of angle F have to equal 180 degrees. Sorry about the bell. Well, that means that Z plus 80 equal 180 degrees. And so Z had to have been 100 degrees. Same concept here for 120 and Y. Well, together they have to be 180. That means Y plus 120 equal 180. And Y, of course, is 60 degrees. And that is the focus of inscribed polygons, specifically right triangles and quadrilaterals. On to the next one.